Hey everyone! In this beginner-friendly tutorial, we're going to build a fun little game using Phaser 3, a candy catching game. You'll learn how to make candy fall from the sky, move a basket left and right, detect collisions, track score and time, and even add background music and sound effects, all using phaserlauncher, a free beginner-focused app for making Phaser games quickly and easily. Let's start by downloading phaserlauncher. Head over to phaser.io/download/phaser-launcher. There'll be a link in the video description, and you'll find links for both Windows and Mac OS. Phaserlauncher is an all-in-one app that comes with a code editor, a media browser, a game preview runner, and built-in tutorials, and best of all, no need to worry about setting up Node or a local web server. It's about 60 megabytes and installs within seconds. To download Phaserlauncher, click on one of the links for your operating system. Once you've downloaded and installed Phaserlauncher, go ahead and launch the app. You'll be greeted with this splash screen here where you need to sign in to your Phaser account. If you don't have a Phaser account, it's free and is really quick to set up. Once you click the sign in button, this should open up your web browser where you can log into your account. Once you've logged into your account, you should be redirected back to Phaserlauncher where you'll see the home screen. So on the home page, you'll find the latest Phaser games, news, and tutorials, as well as the most recent projects you've been working on. If you click on the vertical blades, you'll be able to navigate to the different parts of the app, such as your projects, the first game tutorial, and then the Phaser book. To start building our game, let's go to the Projects tab. We'll click on the New button to create a new project, and here we'll be presented with a list of templates that we can use to bootstrap our game. For our game, we're going to choose the basic template. Now we'll need to choose a folder path of where we want to save our projects. I'm going to make a new folder. I'm just going to call this Phaserlauncher. Open that folder. We need to give our project a name. I'm going to call this Candy Catch. So once we choose Create, Phaserlauncher is going to launch our code editor, and it's going to set up all of the project files we need for our game. The code editor is where we'll do all of the coding for our game. On the left of the editor are the files for our project. We can click on our folders to expand them and see our nested files within there. Double-click on any file to open it up and start editing. At the top, this is where we can add new files and folders, as well as collapse our project files. At the top of the editor is our play button, and this is going to launch our local dev server and allow us to test our game locally. At the top right, we have links to open up the media browser, the documentation, or to create a brand new Phaser scene. To make sure everything's working properly, let's click the play button, and this will start our local web server so we can test our game. So in the new window that opens, we should see our Phaser 3 game based on the template that we selected. So before we start building our project, let's quickly review our project template files. Our project.config, this is just a configuration file for Phaserlauncher. For the time being, we can ignore this file. Our index.html, this will be our main web page that we show to the users when they play our game. Inside that page, we're going to have a link to the Phaser library, as well as the source code that we're going to write to create our Phaser game configuration. Our assets folder, this will have all the assets that we need to load and use in our game. This will include things like images, audio, sprite sheets, and much more. And then under our source folder, this is where we're going to write all of our code for our game. Our main.js file, this is our main entry point for our web app. And then this is where we create our Phaser game instance and provide all of our game settings that we like to use. Under our scenes folder in start.js, this is where we create our Phaser scene, where we render out all of the game objects that we saw when we tested our template. We'll dive more into these concepts as we start building out our project. Before we start working on the code for our game, we first need to load in the assets that we'll use for our project. In the description of this video, there's going to be a link to a direct download to a zip folder that'll have all of our audio, our images, and our sprite sheets we'll use for our game. So if you can download that zip folder and open it up, you should see the following folder structure. You should have 3 folders: audio, images, and sprite sheets. To load these assets in our project, we'll come back to Phaserlauncher. Let's open up our media browser. We'll be able to drag and drop our assets here to add them to our project. To help keep our project organized, let's make 3 folders. Let's do audio, we'll do images, and then let's do sprite sheets. So once we have our 3 folders, let's open up our audio folder. From our assets folder, let's drag and drop our 2 audio files over to our project, and now we'll do the same thing for our 2 other folders. So we'll add in our 3 images, go into our sprite sheets, and we'll add in our 2 sprite sheet files. So now while we're here, let's clean up our 3 asset files that are tied to our project template. So if we right click, we can do delete, and this will remove our phaser PNG, the space PNG, and our spaceship PNG. So now over in our inspector panel, under our assets folder, we should see our 3 new folders that we added with our individual assets for each folder. So one thing to call out, when we use our media browser to add assets to our project, phaserlauncher is not going to move those assets from their original location. Instead, phaserlauncher is going to make a copy of that asset and then place it inside our project. With our project assets in place, we can start working on the code for our project. We'll start by setting up our game scene. In Phaser 3, a scene is like a self-contained section of your game. It could be your main menu, a level, a game over scene, or even a cutscene. Each scene has its own code that handles its own logic, like loading assets, creating objects, updating our gameplay, and cleaning up code when our scene ends. A good analogy for our Phaser game and our scenes is if you think of your game as a play, and each scene is a different act. You switch between your acts or our scenes depending on what's happening in our story or our game. So a good example is when you typically launch a game, you'll see a splash screen where you'll see some logos tied to the company that created that game. This will eventually transition to either a cutscene or the title scene of the game. And then from here, the player will have options to do things like update the game options, view the credits, load their saved game, start a new game. And then from there, depending on the option the player chooses, this could transition to another scene. And so at a high level, when we create our Phaser game instance, you'll always at least have one scene. For your game, it's totally up to you for how many scenes you want to use in your project. So in your scene instance, there's going to be 3 main methods where you'll want to add your code. First will be your preload method. This is where you'll typically add in any code where you need to load assets that you want to use for your game. Once you've told Phaser about the assets you want to load, Phaser is going to hold off on calling our create method until those assets have been loaded and they're ready to be used by our game. Once they're ready, Phaser is going to invoke our create method, and inside here, this is where we set up our game objects that we want to use. So this would be like adding our background image, creating our sprite game objects, creating animations. And so this is where we do things like create our background image, add our text game objects, add our sprites that we want to move around our scene, and much more. And then finally, we have our update method. And this method is going to be invoked for every tick of our game loop. And so inside here, this is where we'll typically check for player input to move our game objects around our scene, and we'll do our physics update for our game. And so that's just a very high level view of Phaser scenes. If you're interested in learning more, if you click on the documentation link here, this is going to open up the Phaser documentation site. And on the main page on the sidebar, there is a high level breakdown of each of the core concepts in Phaser. From here, you can click on scenes, and this is going to give you a deep dive into Phaser scenes and all the different things you can do. To start creating our game scene, we're going to create a new scene file for our project. To do this, in the top right hand corner, if we choose the create scene button, here we can provide the name for our scene. So I'm going to call this game scene.js. Click the accept button. phaserlauncher is going to create the main boilerplate that we need for our Phaser scene class. So inside our class, we're going to have 3 methods. We've already went over preload and create. How init is used, this is used for initializing any values that we want to set up for our scene. When our scene is first launched, this method will be called by our scene manager. And so this method is useful for setting up and initializing any values that we need in our scene. Besides that, we have our constructor, where we're calling super, so we can call the constructor on our parent class. And inside here, we're passing 1 argument, and we're passing in the name of our class. So this argument, this is going to be the unique identifier for our Phaser scene. This is important because each scene in Phaser needs to have a unique identifier, and that identifier is how Phaser knows to reference this scene instance. We'll also use that same identifier when we want to reference our other scenes in our code. So now that we have our new scene instance, we need to update our Phaser game configuration to use our game scene instead of our start scene. So if we open up our main.js file, first we need to update our import. So let's do /scenes, and then we'll do our game scene. Instead of importing start, we're going to import game scene. And now we need to update our scenes array here to reference our game scene. So now if we want to test our changes, let's launch our game. And now in our game viewer, once our game launches, we're just going to see this black canvas here. What's happening is in our game scene, we've not imported any of our assets and we've not created any game objects. And so when Phaser launches our scene, it's not rendering anything out. Instead, it's using our game settings to update our canvas element color and not do anything else. And so if we update our background color to be something like white, we'll see when our game reloads in our game viewer, our canvas element is now updated with that color. So now that we've created our new game scene, and we've updated our game configuration to use our new scene, let's add in our background image for our project. So to use images and other assets in our Phaser game, it's not enough to just add those to our project. We need to tell Phaser to load these when our game is actually running. To do that, we can add code in our preload method to have Phaser load in those assets. So as an example, we can use this.load to reference our loader plugin, and then on our loader plugin, we can tell our plugin which type of asset we want to load. So either an image, a sprite sheet, an audio file, and then we can provide our arguments to have Phaser load in that asset. So to load in our background image, we can do this.load, and we'll do image, and then we need to provide two arguments. Our first argument is going to be our unique key for this asset, and this key is how we'll be able to reference the image data that we load when we want to create and render that image in our game. Our second argument is going to be the URL or our path to our file that we want to load in. So to get the correct file path, if we right click on our background image here, we can do copy path. And now if we update our string here, we'll see its assets, images, and then our background image. And so that matches our file path here. So now for our key, I'm just going to call this background. And now all we've done so far is we've just told Phaser we want to load in our asset. So now if we want to render out this image to our game, we need to create an image game object. And so to do that, we can do this.add.image, and then we can provide the arguments for creating that image game object in our game. So what we're doing here is this.add is going to reference our game object factory, which provides a variety of methods to quickly create new game object types. And when we use the image method, this allows us to add an image game object to our game. When we call this method, we can provide our X and Y coordinates of where we want to position our game object in our scene, and then we provide our asset key that we want to load. And so this key here needs to reference the key that we used when we loaded our asset here. So we're going to update this to be background, and now we're going to update our X and Y value, and so I'm just going to do 0, 0 for our X and Y. So now if we launch our game, now when our scene starts, we should see our black canvas element, and we should see part of our background image being displayed in our scene. And so what's happening here is anytime we want to position a game object in our scene, we need to provide an X and Y value. That X and Y value is going to translate to our game coordinates when Phaser goes to render out that game object. By default, our top left-hand corner is going to be 0, 0, and as we move to the right, our X value is going to increase, and as we move down, our Y value is going to increase. Now when we create a game object, Phaser is going to use the origin of our game object to position that game object in the position we specify. So by default, your game object's origin is going to be in the center of it. And so right now, our game object is going to be in the center of our image here. So about right here on our green ice cream cone. Since that is our center, because we're using 0, 0 for our location, Phaser is going to position our game object at that location. So now if we try updating our X and Y values, so if I try doing something like 1,000 for our X value, this should now shift our game object over 1,000 pixels, and so now our origin is here at 1,000 pixels. Likewise, if we update our Y value to something like 500, our game object should now shift down, and now our center of our game object is right here at 1,500. So now for each of our game objects, we also have the ability to update the origin on our game object. We can do that by calling setOrigin. This allows us to provide both a value for X and Y. Now this value needs to be a value between 0 and 1, and by default is 0.5, which will be the middle. If we want our origin to be in the top left-hand corner, we can provide 0, 0, or just 0 for both our X and Y value. And if we save, our game object's origin is going to be updated. So now the top left-hand corner of our image is at our position 1,500. So now if we change this back to 0, 0, and we save, now we can see that our image is being positioned in our top left-hand corner. Now, let's load in our basket image, and we'll display this at the bottom of our screen. To do this, let's copy our line of code in our preload method. We'll need to tell Phaser to load in our new asset, call this basket. Now for our path, it'll be under our assets, our images, and it's going to be our basket PNG. And now to create our game object, Let's copy this line of code here, paste it. We'll want to update our asset reference, so we'll want to use our key basket. Let's remove our code for update our origin. And now for our positioning, we'll want this to be in the center of our screen. To easily get this value, we can use our scale manager. So if we do this to reference our scene, let's do scale to get our scale manager. And now we can access our width and height of our scene. So we'll take our width, we'll divide it by 2, so we'll be in the center. So now for our Y value, let's set this to 630. Now if we save and come over to our game, we'll see our new game object is added to our scene. Now our basket is a little bit hard to see against our backdrop, so we're going to add a glow effect to our game object. To add our glow effect, we'll need to get a reference to our basket game object that we just added. So let's store this on a property on our class. So we'll do this.basket will be equal to this.add.image, and now this will store a reference to our image game object. Now for our glow effect, let's do this.basket glow, and now we can reference this.basket, and now we can reference our postfx pipeline, and we'll do add glow. And now for our special effect, we can choose which color we like to do. We want to do white, so let's do 0x, FF, FF, FF. And now for our outer strength, we'll do 3, and we'll do 0 for our inner strength. Now if we save, if we come back over to our scene, now we have this nice white glowing effect around our game object. Now that we've added the basket to the game and positioned it on our screen, it's time to make the gameplay come to life. We want candies to fall from the top of our screen, and we want the player to catch them with the basket. To do that, we'll use something called Phaser Arcade Physics. Arcade Physics is a lightweight system built into Phaser that makes it easy to add gravity, movement, and collision detection to game objects, all without needing to write complex math. Before we can use it, we need to make sure it's enabled in our game configuration. In our main.js, under our config object, let's add a new property, and this is going to be physics. This property will be an object, and on this object, we're going to add a default property, and this will tell Phaser what's the default physics system we want to use for our game, and we want to use arcade. Once we tell Phaser which physics system we want to use, we need to provide a property that's an object with our configuration for that physics system. So now we're going to add a property called arcade. This will be our object. And now we can do things like specify gravity and enable debugging to help us test our code. So we'll add in our gravity object, and here we can set our x and y value. So we're going to set x to be 0, and we'll set y to be 200. And now we'll add in debug, and we're going to set this to be true. Now that we told Phaser about our physics system that we want to use, if we come over to our game, it looks like nothing has changed. In order to use our physics system, we need to use special game object types in order to interact with our arcade physics. To do this, let's come back to our game scene. Instead of using this.add.image to create an image game object, we want to create an arcade image game object, and then that's going to enable it for physics. To do that, if we do this.physics, and then we do .add to reference our game object factory on our arcade physics system, and then from there, we'll be able to create our image game object. So now if we save and come back to our game, if we reload, we'll see right away our basket gets added, and we see this purple box around our game object. That box shows our game object has a physics body, and now our physics are affecting our game object. In our game configuration, since we set our gravity for our y value to be 200, that means we have a gravitational force pushing down on our game objects, which is causing our basket to fall automatically. If I change this to something like 5 and we come back over, we'll see our game object starts falling, but it's much slower. Likewise, if we set this to 0, we'll see there's no gravitational push on our game object, and so our game object doesn't move. So we'll revert this back to 200. Now for our basket, we don't want gravity to affect this game object. So to fix that, we can update some of the properties on our physics body so it won't actually move. So to do that, let's reference our basket. Now we want to reference our physics body, and now we'll do set allow gravity. We'll set this to be false, so now gravity is not going to affect our game object. Alright, so now if we save, let's come back over to our game, and we'll see our gravity is no longer affecting our basket. Next, let's make the basket move left and right using our keyboard. We'll listen for our left and right arrow keys, and when these keys are pressed, we'll move our basket smoothly across our screen. To listen for input on our keyboard, and specifically for our arrow keys, we're going to use a method that will allow us to bind listeners for our up, down, left, and right keys. So let's make a new property. We're going to call this cursor keys. We're going to set this equal to this. We'll do our input. Let's do our keyboard. And now do create cursor keys. And this will return an object that has hotkeys for our arrow keys on our keyboard. Now that we have our object with our hotkeys, we need to react to when a player presses one of these keys and then update our basket game object. To do that check, we're going to add the update method to our class. Now our update method, this is going to be called once per game step while our game scene is running. So it's inside this method, this is where we want to do things like where we handle player input or update our game object's positioning. So now to check for input, we're going to use our cursor keys property. So we're going to do if this, our cursor keys. Now on our object, we have a reference to our 4 arrow keys. So we'll check for our left key. Now on this object, this gives us properties to check to see if our key is currently being pressed down. So we're going to use our isDown property. And so if our key is being pressed down, I'm just going to do a console log and we'll say left key pressed. Besides our left key, we'll want to check to see if our right key is being pressed. And so we're going to do else if this, our cursor keys, our right key is down. Now we'll log in a message where our right key is being pressed. Otherwise, we'll do else and we'll just say console.log, neither key is pressed. Now, if we save and come back over to our game, we'll see right away in our console, our message for neither key is being pressed is being logged multiple times per second. Now, if we press our left key, we'll see our message tied to our left key is being logged. And if we press our right key, we see our right key message. So now that we have our input working, now we want to update our game object's velocity to move it across our screen. So down in our update method, when our left key is being pressed, we'll want to update our X velocity and we'll want to set it to a negative value so we move to the left. So we'll do this, we'll reference our basket game object, and now we want to do set velocity X, and now let's do negative 350. Let's copy that line of code. Let's get rid of our console log statements. And now for our right key, we want to do a positive 350. And then our else block, we want to reset this back to 0 if neither of our keys are being pressed. So now if we come back over to our browser, if we press our left key, we'll see our game object starts moving across our screen depending on which key we press. So now for our game object, we're able to move it outside our scene. We want to keep our game object within our game view here. To do that, we'll need to update a property on our game object body. So if we call set allow gravity, we'll do set collide world bounds, and we're going to set this to be true. What this method will do is going to update that property, so now our game object body is going to collide with the edge of our world that we have defined here. So now if we press left and right, our game object can't leave our scene. Now for the fun part, dropping candy from the sky. We'll create a physics group to hold our candy objects and use a repeating timed event to spawn new candies at random horizontal positions every second. Each candy will fall thanks to gravity, no animation is needed. To start spawning in our candies, first we need to load in our assets that are tied to our candy sprites. Under our media browser, under our sprite sheets folder, we have this candy sprite sheet here, and this is a sprite sheet that's made up of multiple smaller images or frames that we'll want to render out for each of our candies. Now our JSON file, this has metadata that's going to tell Phaser how we can load in this image and break it up into smaller images or frames we want to use in our game. So to use this sprite sheet properly, we'll need to tell Phaser to load in this asset and use that JSON for our parsing. To do that in our game scene, in our preload method, we'll do this, we'll do load, and now we want to use the atlas method to load in our special sprite sheet. So now we need to provide our key of our assets that we want to use for caching. So we're just going to call this candy. Now we need to provide the path to our sprite sheet. So under our assets folder, under sprite sheets, if we right click on our PNG, let's do copy path. Let's paste that in. And now we need to provide the path to our JSON file. So we'll do the same thing. So let's do copy path. We'll paste in our string. So now we told Phaser to load in our sprite sheet and how to parse our sprite sheet. We can now use that to create our game objects. So to make sure everything's working in our create method, let's do this. So we'll do physics. We'll do add. Let's do an image. And now for our X value, let's just do 50. For our Y value, we'll do 0. And now for our texture, we'll do candy to reference our key from our sprite sheet here. And since we're using a sprite sheet, we can provide an optional frame that we want to use from our sprite sheet here. For now, we'll omit this value, which will cause us to use the first frame in our asset. So now if we save and come over to our game, we'll see now we have our new candy game object being added to our scene. And since it's a physics game object, it's now falling automatically due to our gravity. Now that we've added in one candy game object to our game, now we need to add in our logic to keep spawning candies every second in our game. To do this, we're going to use what's called a timer event in Phaser. A timer event is a way for us to schedule code to run later in our game after a set amount of time has passed. With our timer events, we can also have these be repeatable events, so then that way we can do things like after 1 second has passed, spawn a new candy, wait another second, and then spawn another candy. To see an example of how this works, let's do this. We'll do time to reference our clock plugin, and now we'll do add event. And now add event allows us to provide our configuration for that timer event we want to create. So in this configuration, we can do things like specify a delay, so how long we want to wait before our timer does what we want it to do. So we're going to do 1 second. Then we can provide if we want our timer to loop or not, and we're going to set this to be true. And what this means is our timer will keep repeating every 1 second in our game. And then we can provide a callback function, which is a function we can run after the second has passed. For this, we'll make a new method on our class, and we're going to call this spawn random candy. And then we can provide our callback scope, and we want to pass in this to reference the scope of our class here. So now that we're referencing our new method, we need to add that to our class. So at the bottom of our class, let's do spawn random candy. Now all I'm going to do inside this method is I'm going to take my code here before we spawn our candy. Let's remove it from here. We'll paste it down here. Alright, so now if we save, if we come over to our game, we'll see after 1 second has passed, we spawn our first game object, and then every second after that, we're spawning a brand new game object, adding it to our scene, and then it's falling automatically. So now that we have our timer event working, we'll want to update our game object to be in a random location and to choose a random frame from our sprite sheet. So now to choose a random location, we're going to use some of our phaser utility functions for choosing a random value. To do that, we're going to do phaser, we're going to do math, we'll do R&D for random, and now we want to do between. This method allows us to provide a minimum value and a maximum value, and then phaser is going to choose a random number inside that range. So let's do 50 for our minimum value. For our maximum value, we want the full width of our game, but then we want to subtract 50 pixels, so that way we're within the bounds of our game. So we're going to do this, we'll do our scale. For our scale manager, we'll grab our width property, and we're going to subtract 50. For our Y value, let's do -20, so we spawn the game object outside our game, and then it's going to fall from the top. Now if we save and come back to our game, we'll see now when our game objects spawn, they have a random X value, and so they're spawning at different locations. So now our game objects are quite large, so let's make them a little bit smaller. To do that, we can use our set scale property on our game object. And what this will do is it allows us to shrink or grow our game object by the value we specify. So we're going to do 0.5 to make our game objects half the size they were before, and now our donuts that are spawning are much smaller. So now for our candy, it'd be pretty boring if we keep spawning the same game object over and over again, so we'll want to choose a random frame from our game objects. And so to update our candy's frame, we need to get a reference to our frame names that are used from our sprite sheet. So when we load in our sprite sheet, we use this JSON file here to tell Phaser about each of our frames that exist in our sprite sheet PNG here. So if we want to load in a different asset, we need to use this frame name here so Phaser knows which frame we're trying to show for our candy game object. So as an example, if I copy this candy-3 PNG, we come to our game scene. When we go to create our game object, after we provide our texture, if we provide that as our frame name and save, we'll see now when we spawn our game object, we're now using that frame when we spawn that game object. And so to make this dynamic, we want to grab this from one of our frame names that Phaser has a reference to. To do that, we'll come up to the top of our create method. Before we create our timer event, we're going to store a reference to all of our frame names that Phaser is aware of. So we're going to do this. Let's do our candy frames. We're going to set equal to this. We're going to reference our textures to get our textures manager. And now we want to do get. We want to provide our texture key that we loaded in, so our candy. And now we're going to use the method getFrameNames, and this is going to return an array of all of those frame names from our JSON file here. So now that we have an array of all of our frame names, we can choose a random element from that array when we spawn our game object. So now to choose a random frame, we're going to use some of our phaser utility methods. So we're going to do phaser. Let's do our utils. We want to do our array utils. We're going to do getRandom. This method allows us to provide an array, and then Phaser is going to randomly choose an element from that array and return it to us. So we're going to reference our candy frames. And now if we save, come back to our game, we'll see now when we spawn our game objects, each candy that's spawning is using one of our random frames from that array. Now that we have our basic logic for spawning game objects working in our scene, we'll want to optimize our code. So currently, we're creating a new game object every second in our game, and then Phaser is updating our X and Y value based on the gravity that's being applied to each of our game objects. Now because our world is infinite in our X and Y values, our number of game objects is going to keep building up as we add them to our game. One way to optimize this is once our game object leaves our scene view here, because our player can't actually move up and down, we can clean up that game object from our scene. Instead of doing that, we're going to create what's called an object pool, and this object pool will allow us to reuse our game objects that we've already created and then respawn them up here at the top of our game. An easy way to create an object pool in Phaser is to use what's called a group. And so we're going to update our logic to use a Phaser group when we spawn our candy game objects. To do this, first we need to create our Phaser group. So up in our create method, after we grab our candy frames, let's make a new property. We're going to call this candy group. We're going to set this equal to this, our physics. Let's do add, and then we'll do group. And now for our group, we can provide an array of game objects that already exist. For our game, since we have no candy game objects yet, we'll just pass in an empty array. So now down in our spawn random candy method, instead of using this.physics.add to add our game objects, we're going to rely on our physics group to create a game object when we need one. To do that, we can do this, we can reference our candy group, and then we'll use the getFirstDead method. And what this method allows us to do is we can check to see if we have an existing game object that's not being used in our group, and if so, it'll return that game object to us. If there's no game object that is currently available, we can create a new one on the fly using the properties we provide. So for our first argument, we'll do create if null. We're going to set that to be true, since we want to create a new game object if one's not available. Then for our next two arguments, we can provide an X and Y value of where we want this game object to be placed. So let's copy our code here for our random X and our Y value, and then we can provide our texture and our frame that we want to use. So for our texture, we'll do candy, and now we want to do our random frame. For that, we're going to store that in a variable outside our method. So let's copy our logic here for getting our random frame. And let's do const, we'll do candy frame. We'll set that equal to our Phaser utils, and now we'll pass that in here. So now when we get firstDead, this is going to return a reference to the game object that already exists or the new one that gets created. So let's store that in a variable. So we'll do const candy will be equal to this.candy group. And now that we have a reference to our candy game object, we'll want to update our scale property. So let's copy this logic here, and we're going to do candy. We'll do candy set scale, and we'll set our scale to 0.5. So now if we save, let's come back over to our game. Our game should be running just like it did before. All we've done so far is we've just updated how we're creating our game objects in our game. Instead of manually creating our game objects using this.physics.add, we're relying on our physics group to automatically create our game objects. And so in our spawn random candy method, I'm going to add in a quick console log, and I'm just going to reference our physics group. So we're going to do this, our candy group, and I'm going to do get children to get a reference to all of our game objects in our group, and I'm going to log out the length of that array. So now if we come back to our game, and so we'll see as each game object is spawned, our array of game objects keeps growing. So to make use of our object pool, once our game object leaves our view, we'll want to disable that game object, then that way we can reuse it in our game. To do that, let's go to our update method. So to make our game objects not active, in our update method, we'll want to check our candy game object's Y position. If it's outside our current view, then we'll make our game object not visible and we'll disable it. So in our update method, after we do our check for our input, let's get a reference to all of our game objects in our group. So we'll do this, our candy group. Let's do get children. Now this will return an array of all of our game objects, and now we'll use for each to iterate through our array. So now we'll have our child game object, and inside our callback here, first we'll make sure our game object is active, and so we'll do if not our child is active. Then we want to return early. This means we've already disabled that game object and we don't need to do our check for our Y value here, so we're just going to return early. If our game object is active, now we want to check that game object's Y position. If it's greater than this, our scale manager, our height, and we'll add some padding, and so we're just going to do 10 pixels. Then we want to disable our game object, so we'll do our child, we're going to set active, we're going to set it to be false, and then we'll call set visible to hide our game object. And so we'll do false. Now if we save, come back to our game, we'll see after we spawn our first 3 game objects, we'll start seeing the number 3 repeat in our console. What's happening is since we're disabling our game objects, when we do our getFirstDead method here, it's returning that instance. Since that game object already exists, it has its active property set to false and our visible property set to false, and that's why we can't see our game objects when they're spawning. Also, our game object's velocity is at its original value, and so that's why our objects are speeding up and they're moving so fast. So when we return an instance of our game object, we'll want to reset those values, and then that way it's spawning like our initial candy. So after we call setScale, first we'll make our game object active, and so we're going to do setActive. We'll set that to be true. Now we want to make our game object visible, so we'll do setVisible, set that to be true. And now we'll want to reset our game object's velocity, and so we'll do setVelocity, and we'll set this to be 0. Now if we save, let's come back to our game. We'll see our game object spawns. We eventually get to our 3rd game object, and now we're repeating having our game object spawn. So one thing we'll notice is we're repeating our pattern on our game object's frames. So we have our candy, our ice cream cone, our donut, then candy, ice cream cone, donut, and it just repeats. What's happening is when we use our getFirstDead method, our properties for our X and Y value will be applied to our game object that we're retrieving from our group, but if we already have an existing game object, then our texture and our frame that we're applying will not be applied to that game object. So if we want to use a random frame, we'll need to update our frame on our candy instance here once we get a reference to our game object. So after we call setVelocity, let's do setFrame. Since we're going to set our frame on any of our candy instances, we're just going to move this block of code here inside our call here, and let's remove it from our line of code here when we get our object reference, and we'll just use our default frame when we spawn our game object initially. So now if we save, let's come back to our game. Now, when we spawn our game objects, we should notice that we are using a random frame every time we respawn that game object. So now to make our game more interactive, we're going to add in our check for our collisions between our basket and our candies by using our arcade physics system. We're going to introduce a score mechanic. So when our basket catches one of our candies, we're going to increase our score. We'll then disable our game object so we can reuse it in our object pool, and then we'll play a sound to let the player know they caught the candy. To check for collisions between our candies and our basket game objects, we need to use what's called a collider game object. Our collider allows us to specify one or more game objects that we want to check for collisions with. And when Phaser's arcade physics system detects an overlap in our arcade physics bodies, so our 2 purple boxes here, once they start touching and overlap, this allows us to provide a callback function that will be invoked anytime our 2 game objects start colliding. To add in this collider in our create method, after we do our timer event, let's do this. We'll do physics to reference our physics system. We'll do add, and now let's do overlap. So now the overlap method allows us to be notified when our game object's bodies start touching and they're overlapping in our game. This is different than the collide method where we want to apply physics when our 2 game objects collide together in our scene. So now in our overlap method, first we want to provide our first game object or group we want to check for collisions with. So this is going to be our basket game object. And then for our second argument, we're going to do our candy group. And now we can provide a callback function that we want to be invoked when this overlap happens in our game. So we're going to make a new method for this. We'll do this. We'll call this handle basket candy collision. Now for our process callback, we're going to set this to be null. And now for our callback scope, we want to pass in this. So we have this instance of our scene. So now let's copy our method name. We'll add that method to the bottom of our class. So we're going to have our handle basket candy collision method. And so now when this callback is invoked, we're we're going to receive as arguments our two game objects that our collision is happening with. So we'll have our basket game object, and then we'll have our candy game object. For the time being, we're just going to do console.log, and we'll do our candy game object. So now if we come back to our game, now if we move our basket and try to catch one of our candies, we're going to see right away we start getting a bunch of events in our console. What's happening is when our game objects start overlapping, this triggers our callback, and it happens every update or every tick of our game loop. And so once our game objects start colliding, if we want to make sure we only process this event one time, we need to disable our physics body on our candy game object. So back in our method, on our candy game object, we're going to do disable body. So this method allows us to provide two arguments. Our first one is if we want to set our active property to be false, we want this to be true. And then if we want to hide our game object once we disable our body, we also want that to be true. So by making our game object not active and by making it not visible, we'll make sure to reuse that candy game object in our spawn random candy method. Now if we come back to our game, let's start spawning our candies. Now when our basket overlaps with one of our candies, we'll see we're only logging our event one time. Now with the new logic we've added, we'll see there's an issue with our game objects and when we go to spawn them. So we have this buildup of these purple boxes, which are our physics bodies for our candy game objects. Instead of reusing our game objects properly, we're leaving our physics bodies right here and we're not respawning our game object. To fix this, we need to go into our spawn candy logic, and since we're disabling our body, we need to re-enable that once we get our candy game object instance. So after we call set frame, let's call enable body. Alright, so when we call enable body, this is going to re-enable our game object's physics body. We don't need to pass anything for our arguments, so if we save, let's come back to our game. Now, when our game object starts spawning, let's try to catch some of our candies. We'll see right away our candy's physics body stays right by our basket, but once we respawn our game object, we're resetting our physics body's location. So now that we have our collision detection working, let's add in our score mechanic. For our score mechanic, first let's add a property to our class to keep track of our score. Let's come to our create method. At the top of our method, let's do this.score. We'll set it to be equal to 0. So now down our handle basket candy collision method, after we disable our body, we'll increment our score by 10. So we're going to do this.score. We'll do plus equals 10. So I'm going to move our console log statement below our score. Now instead of logging out our candy game object, let's log out this.score. Now if we come back to our game, let's try to catch some of our candies. We'll see now we're logging out our score, so we're incrementing by 10. Finally, let's add in our sound effect that will play once we catch one of our candies. So to play a sound effect once we catch one of our candies, we first need to load in any of the audio assets we want to use for our game. We'll need to load these assets inside our preload method. So at the bottom of our method, let's do this, we'll do load. And now we want to load an audio file, so we're going to use our audio method. And like our other methods, first we need to provide our cache key of where we're going to store the data related to our audio file. So we're just going to call this pop. And now we need to provide the path to the audio file that we want to load. So under our audio folder, let's right click on our pop.mp3, we're going to do copy path, and then we'll pass in that path as our argument. So now that we've loaded our audio file, we can now use our sound manager to play our audio. So if we come down to our method for our collision detection, after we increment our score, to play our sound effect, we need to do this. We need to do sound to reference our sound manager. And now we want to do play. And then in this method, we can provide our asset key for the sound we want to play. So this is going to match our key that we provided up here when we loaded in our audio file. So we want to pass in pop. And then for our second argument, we can provide some additional settings for our sound. One of these is we can set our volume property, and so we can decrease the overall volume of one of our sound files when it plays. For our value, we want to pass a number between 0 and 1, and so if I pass in 0.5, this will make our sound effect only play at half of the volume of the original audio file. So this is nice if you have different files that play at different volumes. So now if we come back over to our game, if we try to catch one of our candies, we should now hear our pop effect play. With our logic for catching candies in place, let's add a simple UI to keep track of our score. We'll show the player how many points they've earned from the candies they have caught. To create our simple UI, we're going to use a phaser text game object. Our text game object is a way for us to display simple text in our game. Our object allows us to do things like specify the font we want to use for our text, our color, our size, and then our styling. So to create this game object, let's come back to our game scene. Up in our create method, after we do our collision detection, let's do this.add, and we'll do text to create our text game object. Now we want to do our x and y value, so we'll do 10 for our x, 10 for our y, and now we want to provide our string that we want to display in our game. For this, we're going to do score, we'll do colon, and then 0 for our starting score. Now we can provide our text styling we want to apply to our game object. So inside this object, we're going to do font size. We'll set this to 40 pixels. Next, we'll do our color. We're going to do 043 D8C. So now if we save, let's come back to our game. We'll see right away in our top right hand corner, we have our new text game object. So our text game object is using our blue color that we specified here, as well as our font size. So if I bump this to like 22 pixels, we'll see our game object gets recreated and it's much smaller. So right now our text game object is a little bit bland, and so to make it pop out, we're going to add a white outline around our game object. We can use our stroke property, so for our stroke, this will be our color we want to apply. Let's do white, so we'll do FFF, FFF, and now we want to provide our stroke thickness, and so this is how thick the line around our text is going to be. We'll do 6. We come back to our game, we'll see now we have this white border around our text. And so if we modify our stroke thickness to be like 2, we'll see our white outline is much smaller. So now that we have our text game object, we need to update our text when our score increases. To do this, we're going to break our game object up into 2 game objects. One that's going to have our prefix of just our score, and then we'll have our text game object that actually has our score value. We need to store our reference to this game object, so we'll do const, we'll do score prefix, we're set equal to this.add.text, and now we want to do our suffix for our score, and we're going to store that as a property on our class. So we'll do this. We'll do our score text. We'll set it equal to. Let's copy our game object here. We'll paste it. Let's remove our score and our colon. And then from here, we'll just remove our 0. We'll keep our same styling. So now for our score text game object, we need to update our X position. We want it to be based on where our score prefix object is currently located in our scene. So let's reference score prefix. We're going to grab our X value, and now we want to grab the width of our game object so we won't be overlapping with that game object. So we'll do our score prefix, and we'll do our width. Now if we save, we'll come back to our game, and we'll see both of our game objects are appearing in our scene. So now to update our score, when our score increases, we'll come down to our handle basket candy collision. After we update our score, we want to reference our score text. And now we can use the set text property to update our text string that we're displaying. And now we need to pass in our score as a string. So we'll do this.score. We'll do toString. Pass in 10 for our radix. Let's save. Now back in our game, let's try catching one of our candies. We'll see now our text game object is updated to reflect our score. With our new UI in place, we now need to give our player a goal for our game. Currently, our player can keep catching candies indefinitely to increase their score. For our game, we're going to introduce a timer. And this timer is going to give the player a set amount of time to catch as many candies as they can to get a high score. To implement this timer, we're going to add a new timer event to our game, which will allow us to keep track of how much time the player has left. Once that timer reaches 0, this will be our trigger for our game to be over, where we can tell the player how many points they have earned. To implement our new timer, let's go into our create method. At the bottom of our method, we'll need to create a new timer event, and we want to store a reference to that event on our class. So let's do this. We'll do timed event. We'll set it equal to this.time.delayedCall. Delayed call allows us to provide a number of milliseconds we want to wait before we invoke our callback function. So now for our game, we'll want our rounds to last 30 seconds, so we'll do 30 times 1000 for milliseconds. And now for our callback function, we're going to add a new method to our class. We'll call this handleGameOver. And then for our callback arguments, we're going to pass in an empty array. And then for our callback scope, we want to pass in this for our instance of our scene. So now we need to add this method to our class. So at the bottom of our class, let's add in handleGameOver. And I'm just going to do a console.log, and we'll say game is over. So now to test our logic, instead of waiting 30 seconds, we're going to bump this down to be 3 seconds. Let's save. If we come back over to our game, after 3 seconds, we should see our message logged to our console. So now for our handle game over method, we're going to want to set a flag on our class to know that our game is over. So let's do this. We'll do game is over. We're going to set that to be true. Now with our new property, we can update our update method and things like our collision checks to see if our game is over. And if our game is over, we can stop increasing our score. So first in our handle basket candy collision, let's do if this game is over. If it's set to true, then we'll just return early. Let's copy that block of code. Let's come up to our update method. We'll add in that same check here. So if our game is over, we don't want to run any of our update logic. And now let's set this property on our class with an initial value. So before our time event, we'll do this.gameIsOver, and we'll set it to be false. So now if we save, all right, so if we come back to our game, let's try moving our basket. And so once our game is over, so it looks like we have an issue. If we're pressing one of our keys when our game ends, our basket will keep moving. So once we do our check for our game is over, we'll want to reset our basket's velocity to make sure it's set to be 0. So we'll just add that within our if check. Let's save. We'll come back to our game. Now if we're moving our basket and our game ends, we stop moving our basket. We're still collecting our candies, but our score stops increasing. So now that our game is over, we want to allow our player to replay our game. For the time being, we're just going to restart our existing scene, and then we'll come back later, and we're going to add in a new game over scene that'll display our player's score that they've earned. So to restart our scene, we'll do this. We'll do scene to reference our scene manager. And now we want to do restart. And now if we save and we come back to our game, after our 3 seconds have passed, our scene should restart and our player can replay our game. So now that we have our basic logic for our game being over, we now need to add in our UI element for our timer. To add in our new element, we need to create a new text game object. So let's come up to the top of our create method. Let's copy our logic for our score text. We'll paste that. We'll add a new property to our class. We'll call this timer text. Now for our position, for our X value, we're going to set this to be this, our scale manager, our width, and we'll subtract 80 from our width. We'll do 10 for our Y. And now for our timer text, we're going to set our initial value to be 30. Now for our font size, let's do 60. We'll keep the same color, stroke, and stroke thickness. So now if we save, let's come back to our game. We'll see our new text game object is visible in our UI. So now we just need to decrement our timer as time is passing in our game. To update our timer text game object, we'll need to come down to our update method. After we do our check for if our game is over, we'll want to call our set text method to update our timer text. So we'll do this, we'll do our timer text, we'll do set text, and now for our text value, we need to get a reference to the number of seconds that are remaining on our timed event. We'll reference this, our timed event game object, and now we can call get remaining seconds. And this is going to return the number of seconds that are remaining until our timer event is going to trigger. Since this returns a number, we're going to call toString, and we'll pass in 10 for our radix. All right, so now if we save, we come back to our game, we'll see right away our timer text is being updated, but it's not a full integer. To fix this, we're going to round our value. So when we call set text, let's do math, we'll do round. So we're going to pass in our get remaining seconds, then we'll call it toString. Now if we come back to our game, we'll see now our timer is updated and it goes 3, 2, 1 till we get to 0 and then our game ends. All right, since we validated our timer is working, let's come back to our code and we'll update our timer to be 30 seconds. Now that we have our logic working for our timer event, we're going to update our game so we'll transition to a new phaser scene once our game is over. In this new scene, we're going to display the text game over with the score that the player earned. To do this, we'll need to add a new scene to our project. To add a brand new scene, in our top right hand corner, we'll do create scene. Now for our scene name, we'll call this game over scene. Now that we've added a new scene to our project, we need to update our game configuration to use this new scene. So if we open up main.js, let's copy our import line statement here. We'll update this to be game over scene. We'll update our import. And now in our scenes array, we want to pass in our game over scene. While we're here, let's update our game title, and we'll call this Candy Catch. Now that we've added our new scene to our game configuration, to use it, we'll need to update our game scene to transition to our game over scene once our game is actually over. So down in our handle game over method, instead of calling this.scene.restart, we'll call this.scene.start, And so what this method will do is we can provide the key of the scene that we want to transition to, and then Phaser is going to shut down this scene and then start the next one. For our scene key, we need to use that string that we provide in our super call in our constructor. So we're going to copy gameOverScene. So we'll pass in gameOverScene as our argument. Let's get rid of our console log, and to make it a little bit easier to test, let's come back up to our logic tied to our timer. We're going to set this back to be 3 seconds. Let's save. Now if we come back to our game, after our 3 seconds have passed, we now see this black screen. So what's happening is we're stopping our game scene, and then we're immediately going over to our game over scene. And because we're not creating any of our game objects, we'll just have that black canvas being displayed to our player. So what we'll do in our game over scene is let's reuse our background that we're using in our game scene. So we go into our create method. Let's copy our logic here before we create our background. Let's paste that in. Now if we save and come back to our game, we'll see right away, once we transition to our game over scene, we now see our background. So one thing to know is we're able to reuse our background image that we loaded in our game scene in our game over scene. The reason we can do that is when Phaser loads in one of our assets, it's going to cache that data for that asset. That way we only have to load it one time for our game, and then we can use it anywhere. So now that we have our background image, let's add in our game over text to our scene. For that, I'm going to come into our create method in our game scene, and I'm going to copy our text game object for our score prefix. We'll come back over to our game over scene. So after we do our background, let's add in our text. So now for our text game object, we'll want to display the text game over. For our position, we want this to be in the middle of our screen. And so we'll do this, we'll do our scale, let's do our width, we'll divide it by 2. And now for our Y value, we'll do the same thing, but we're going to do our height, we'll divide it by 2. And now for our font size, we want this to be a little bit bigger, so let's do 80. We'll do a slightly different color, and so we'll do B05, 389. We'll use our white stroke, and because our text is a little bit bigger, we'll do our stroke thickness of 10. Now if we save and we come back to our game, we'll see our new text game object is added to our scene, but it's not centered in the middle of our canvas. What's happening is by default, our text game objects, our default origin is 0, 0, and this is different than like our image game objects where origin is 0.5. So if we want our game object to be truly centered, we'll need to update our origin. So if we come back to our create method, let's call set origin on our game object, and we'll pass in 0.5. To make it a little bit easier to test while we're adding in our new code, I'm going to go into our game scene, and I'm going to update our timer, and I'm going to set this to be 0.5, and that way we'll transition to our game scene very fast. So now we'll see our game over text is now centered in our scene. So now we'll want to display the score that our player earned, so we'll come back to our game over scene, let's copy our text block here, let's paste it. So now for our text, we'll want to display score, and then we need to pass in our score that our player has earned. So for that, we'll add a new property to our class, we'll call it score. So now for our positioning, we'll keep our same X value, but now for our Y value, we don't want this to be directly in the center, so we're going to add in 60. And since we're doing more than one text game object, we're going to move our game over text a little bit higher in our scene, so we're going to subtract 100 from this. So now for our font size, we'll do 60, and we'll keep the same color and same stroke, but then for our thickness, let's do 8. So now for the time being, we're going to set our score to be 0, so we actually have a value. So up in our init method, let's do this.score, we'll set it to be 0. So now if we save and we come back to our game, we'll see our new score text game object is visible in our game over scene. Now, we just need to pass our score that our player has earned from our game scene to our game over scene. In our game scene, when we call this.scene.start, we can pass a secondary argument, which is an object. This object can have any key and value pairs that we want to pass. And when Phaser starts the scene we provide, this object is going to be available to us in our init method in that scene. So what we can do is in this object, let's add a score property. We're going to set this to be equal to this.score. And now if we come over to our game over scene, we're going to add data as an argument to our init method. And now when we initialize our score, we can set it to be equal to data.score. So now if we save and come back to our game, we'll see once we transition from our game scene, we're passing our score value of 0, and now we're displaying that on our score value here. So now if we want to test passing a value besides 0, we'll update our timer. I'm going to do 5 seconds. Now if we come back to our game, that should give us enough time to catch a candy. Once we do, our score is now set to 10, and once we transition to our game over scene, we now see our score value is being populated. Finally, for our game over scene, we just need to provide a way to let our player restart our game. We're going to allow our player to click anywhere in our scene, and once they do, we'll use our scene.start method to start our game. So if we come over to our game over scene, the bottom of our create method, to listen for input, we're going to do this. We're going to do input to reference our input plugin, and then we'll do the once method to listen for an event. So now the event we want to listen for is going to be our pointer down event, and so now when that event is fired, we need to provide our callback function that we want to invoke when this event is fired. So once this event is fired, we'll do this, we'll do our scene, let's do start, and now we want to start our game scene. So now if we save, let's come back to our game. Once we get to our game over scene, if our player clicks anywhere in our scene, this will stop our game over scene and then restart our game scene. So one last change we'll do is I'm going to add a text game object to let the player know they need to click to play again. So we come back to our game over scene, I'm going to copy our text game object here, we'll paste it. So now for our position, we'll keep our same X value. For our Y value, we'll do this.scale.height, we'll divide it by 2, and we'll add 180. And now for our string, I'm going to say click to play again. Now for our font size, we'll make this a little bit smaller, so we'll do 40 pixels. We'll keep the same color and stroke, but then for our stroke thickness, we'll do 6. Let's save. Now if we come back over to our game, once we get over to our game over scene, we should see our new text game object. Now that we have our game over scene working, we're going to add some polish to our game. Currently, when we transition between our game scene and our game over scene, it's very abrupt and we jumped right into our game. Instead of it happening immediately, we're going to add a nice fade in and fade out effect between our scenes. We can use our phaser camera, which has a built-in effect for doing this fade in and fade out. So to add this fade in effect, we need to reference our main camera and our scene. So in our callback for after the player clicks on our scene, we'll do this. We'll do our cameras to reference our cameras manager. We'll use the main property to reference our main camera. And now we're going to call fade out. When we call this method, we can pass in the number of milliseconds we want the fade out effect to last for. We're going to pass in 500. For the time being, let's comment out our scene.start line. I'm going to come over to our game scene, and I'm going to update our timer event to be 1 second. We come back to our game. So once we're in our game over scene, let's click on our scene, and now we have this nice fade out effect from our camera. What we need to do now is wait for this fade effect to complete, and once it does, now we'll transition over to our game scene. So back in our game over scene code, so in our create method, after we trigger our fade out effect, now we want to listen for the fade out complete event on our camera. To do that, we'll do this.cameras, we'll reference our main camera, and then we'll use the once method to register a one-time event listener. And now for our event, we want to do our phaser, our cameras, our scene 2D, our events, and then our fade out complete. So once this event fires, we need to provide our callback function that we want to be invoked. Now in our callback function, this is where we'll start our game scene. So now we save, let's come back to our game. Once we get over to our game over scene, let's click. We now have that nice fade out effect, but once we get to our game scene, we immediately pop into that scene. To complete our transition, we want to add a fade in effect once we get to that scene. To do that, let's copy this line of code here for our fade out. We'll come to our game scene at the bottom of our create method. Let's paste in that line of code, but instead of doing fade out, we're going to do fade in. So this will have the opposite effect where we're going to start from the color black and we'll fade into our scene. So in order for us to test this, let's update our timer event. I'm going to update this to be 3 seconds. We'll see now right away when our scene starts, we have this nice fade in effect for our game. So now as we get to our game over scene, if we click, we have this nice fade out, then we fade in and we start our game. So now we're just going to do the same thing once we want to transition over to our game over scene. So we come back to our code. Let's copy this line of code here where we fade in our camera. We'll go to our game over scene. At the bottom of our create method, let's paste in that line of code so we'll fade in to our game over scene. Now let's copy our 2 blocks of code here before we do our fade out and we start our game scene. Let's come to our game scene. Let's go to our game over logic. So instead of immediately going right to our game over scene, let's paste in our code here where we do our camera fade out. Then we'll have our event listener for once our fade out is completed. And now we want to start our game over scene, and we want to pass in our data object. Now let's remove our line of code here. Let's save. If we come back to our game, we now have this nice fade in effect. We now fade out to our game over scene and fade in. And now if we click, we have that fade out and we fade back into our game scene. Finally, for our game, the last two things we'll do is we're going to add a new title screen that will present to the player when they first launch our game. Instead of jumping right into the gameplay, we'll have our title screen display the title of our game as well as the text click to play, so they have to click to launch our game. We'll then wrap up by adding some background music to our game. So for our title scene, this will be very similar to our game over scene, where we want to display our background image and then a few text game objects. To create our new scene, let's come back to our code. Let's click our button to create a new scene, and we'll call this title scene. Let's open up our game over scene. Let's copy all of our code from our create method. We'll come back to our title scene. We'll update our code here. So now for our text, let's replace game over with candy catch. For our positioning, we'll want it to be right in the center. So we want to do our width divided by 2, and we'll do our height divided by 2. We'll keep the same font size and color, and our stroke and thickness. Now for our other text, we just want to display click to play. So we can remove our text game object tied to our score. And then for our text, we'll do click to play. We'll keep the same X and Y, and we'll keep the same styling for our text game object. Finally, we'll want to have our nice fade in effect for our scene, and when our player clicks, we want to go into our game scene. So we'll leave this logic as is. So now that we have our new scene, we need to update our game configuration. So let's copy one of our import statements. We'll paste that in. Let's update this to be our title scene. Let's add this as our first scene in our scenes array. So now if we save, let's come back to our game, and we'll see our two text game objects are added, but we see this black background with this broken image icon. What's happening is in our game scene, this is where we have our logic where we load in our assets. Since our title scene is now the first scene we start with in our game, we need to load our assets here so they'll be available to all of our other scenes. So let's take all of our code from our preload method. We'll move that over to our title scene. So now if we save and we come back to our game, we'll see our background image is now loaded and we have our two text game objects. And so if our player clicks, we now transition to our game scene. Finally, to play our background music, we need to load that asset into our game. So let's go to our title scene. Let's copy our line of code for we load our audio asset. We'll paste that in. Now under our audio folder, we have this BG MP3 file. So this is going to be our background music. So for our cache key, I'm just going to call this BG, and we'll do our BG MP3. So now we'll need to play our audio asset. Let's come down to the bottom of our create method, and we'll do this .sound to reference our sound manager. And now we want to do play. And now for our key, we want to do BG to match our asset that we loaded in. And now we want to provide our audio configuration. So now for our background music, we're going to set our volume to 0.5. And one other property we're going to set will be loop. We're going to set this to be true. The loop property is going to tell our sound manager to play this audio file on repeat. So once our audio file finishes playing, Phaser will automatically start playing that sound for us again. So now if we save, let's come back to our game. Once we get to our title screen, we should hear our background music start playing. And if we transition over to our game scene, our audio should continue to play. With our background music in place, that wraps up our game. So before we go, there's a few things we're going to take care of in our code. First, we're going to disable our debug property for our arcade physics, and then we're going to clean up some of our code. So if we come back to our code, let's start over in main.js. In our physics object, let's set debug to be false. Now, let's remove our start.js file from our project. If we open up our title scene, let's clean up our init method. Now if we jump over to our game scene, we can remove our init method from there. Finally, in our game over scene, let's remove our preload method. And now we'll save. Now that we've finished cleaning up our code, we can now bundle up our game and share it with others. To bundle up our game, in the top right hand corner, if we do export zip, this is going to open a modal where we can choose where we want to save our zip folder. I'm going to choose my desktop. Once we click open, phaserlauncher is going to take all of our files from our project and bundle them together into a zip folder. If we open up our zip folder, we'll see all of the assets that we use for our project, our index.html in our Phaser library, and then our source folder where we wrote all our code. Now that you have your bundled up code, you can take your zip folder and upload this to sites like itch.io or GitHub Pages, and then you can share your game with others. And that's it. You just built your first game using Phaser 3 and phaserlauncher. You learned how to move a player, spawn objects, detect overlaps, manage score and time, and add sound, all inside a beginner-friendly dev environment. If you want to go further, try adding different types of candy, power-ups, or even a high score tracker. If you found this helpful, don't forget to like the video, subscribe to the channel for more Phaser tutorials, and leave a comment if you have other game ideas or features you'd like to learn next. Thank you so much for watching, and happy coding!